In our last video, we forked Ethereum Mainnet into Anvil and we were able to interact with contracts on our local Anvil chain. What we're going to do now is we're going to actually deploy a data consumer contract locally to Anvil that will consume the price feed on the forked local chain. What I'm going to do is I'm going to create an env file again. And in the env file, similar to our last Foundry video, I just need the Infura RPC URL to actually fork mainnet. And then we need the Ethereum price feed. So again, go to infura.io and you'll be able to sign up and get your own RPC URL. And that is the address of the Ethereum, of the ETH price feed on Ethereum Mainnet. You can copy that, or if you go to docs.chain.link, you'll be able to find these addresses. Load the env file into our environment. So we're going to make a directory, source, and then we're going to create a file in here, source. It's called data consumer tree.sol. Open that up. And I'm going to copy this from docs.chain.link, and it's in data feeds, and using data feeds you'll find this. This is our data consumer contract. I'm just going to get rid of these comments. Clarity. So I'm not going to import the Chainlink contracts. We're only going to be calling one function on it. So it's going to be, I'm just going to take this out. Let me see, we'll copy this aggregator part. We just need to know what function we're going to be calling. And the function we're going to be calling is a function latest answer. Latest answer external view returns. What does it return? An int. Oh. Okay. And we're going to change probably the Ethereum price feed. There. Just for clarity, this is ETH and it's actually on. Okay. We have an error down here, and that's because this is actually latest answer and it doesn't return all these. So we're going to actually copy all of this. Let me delete this as well. Okay. Tidy this up. Okay. That's our contract. We have our interface there. Latest answer returns int256. Again, this returns an int256. So what we're going to do is we're going to click back in here. We forked our Ethereum mainnet here, which will have an instance of our contract on it. This one here. We're going to do is we're going to actually interact with our contract using the function that we've written. So this function here. What we need to do is we need to create, so forge build file. Okay, there. We're going to forge create source data consumer v3 .sol, which is the file, data consumer v3, which is our the name of the contract. Do private key. We'll just grab a private key from Anvil. This guy. And that will deploy it into our local Anvil chain. And here's our contract. That. Then what we want to do is we want to do cast call. I want to call the contract we've just deployed, and we can see here this is what we're looking to get back. Call, I should say. And what I'll do is this. I'm going to put this in here as well, just so as that it doesn't come back in hex. That should get the result. And there we go. So that's the price of Ethereum. So it's 2100 is the current price of Ethereum, again with 8 decimals after it. So just to briefly illustrate how this will be used in a say an app or something like that. We're just gonna just clear this out, minimize this. We're gonna do redeploy the contract, but we'll do something like this. So you can imagine that this is your whatever. Say it's a stablecoin contract, and you need to get the value of the collateral or something like that. You can say get a collateral value in USD, and we'll say public view returns view. Six. UINT 256. We're going to say it accepts a UINT 256 ETH collateral. Okay, so what we're going to do then is we're going to say we'll copy this. And we're going to implicitly go UINT 256. Say price ETH price. Just gonna set UINT 256. Then what we're going to say is return ETH collateral amount multiplied by ETH price. So essentially what happened here is we'd pass in one, say we were depositing one ETH as collateral, we'd pass it in here and it would multiply it by the price of ETH and return it. 2 ETH, then multiply it by the price of the ETH, and so on and so forth. So we'll just really quickly function on screen for you there. And we're going to redeploy this. So that's the one there. We'll go for it. Go. Contract address. We're going to do fast call to the contract. And this time we're going to say get collateral value in USD. Takes in a UINT 256. So returns a UINT 256. And we're going to pass in. We're going to say, we'll say 1 to start off. It should give it back basically the price of ETH. There you go. And if we pass in 2, it should be what, 4,200 or something like that. Yeah, and so on and so forth as you add more in. So you can kind of see how you would implement it in an application. You would it would be similar to the data consumer. You're really just consuming the Oracle. You're calling to it and getting the price back of it. So you'd be able to calculate stuff like the collateral value that somebody has in an application.